Good morning. Hope everybody is feeling okay. My name is Kristin, CCP Tuxford. I'm the technical director of EVE Online. With me is Nick, CCP Chimichanga, senior development manager at CCP. Or he also goes by a number of different job titles internally. My favorite is director of new technology. So, but welcome to our talk about putting the internet in internet spaceships. What we'll be covering today is how things are now. I'll try to explain a bit how the cluster works from the hardware down into the actual nodes. We'll talk about what problems we have today, and we tell you a little bit about what our future way of solving those are. So this is like a high-level image of our cluster, of our kind of like the hardware connections. You can see it maybe a bit better here, but it has animation. So the client connects to the proxies. Well, it connects to one proxy. The proxy then connects to, each proxy connects to every soul node, which is the actual kind of business logic. And the soul node all connect to each other. The soul nodes then also connect to the database. The proxy does not, however. The soul nodes themselves and the proxy actually as well all are identical in terms of software that's on them. So they basically all can do every job, but in reality each of them has like a different role. So we will have some soul nodes that are just servicing solar systems, and then very specific solar system. These are all kind of stateful services that handle like a single, like a mappable address, something like solar system. Some of them have very few system on them. Jita, for example, is just on its own node. It's actually mapped to a very specific machine as well. Planetary interaction node, those are actually have very little connection to any other code of the game except the inventory system and the accounting, the cash movement. Character, it's handy to have them all on the same node to route all calls from to like a single character to the same node. That means that we can do like a better caching there. So in terms of, this was a huge boost when we did the EVE mails, then we could cache all the data on that node and wouldn't have to go to DB so much. Regional market is one of them, probably, yeah, could imagine that. It's in addition to caching all the market data, it also is kind of authoritative on what what market orders are matched together. Now, if we take a little bit closer look into the solar system node, for example, like I said, there are various stateful services on them. Some of them, such as crime watch. Crime watch is it's basically the law and order. It's what decides what gets penalized. So if you shoot a ship, it tells you like, oh no, that's fine because you're at war, or you get a Concord standing penalty because you're not allowed to shoot them. Beyoncé, rather self-explanatory, right? Although, I guess not really. So our physics system is called Destiny, which you might know, and Destiny's Child was a very popular band. Therefore, the service that is managing the system is called Beyoncé. It's really, really useful to have this little kind of pop quiz questions when you're looking at your code. But that's what Beyoncé does. It's basically managing the solar system simulation. It has various other tasks as well. We have Dogma, that's another fun one. You can't really read it from the name, but basically it's handling all the attribute management and activating and stopping effects and stuff like that. Because a lot of stuff uses attributes, there's also a bunch of other stuff in there. Now, and we have something like a scan manager. Now, scan manager is probably the only usefully named service there. Because you can probably imagine what it does, right? Like, hands up, who knows what this does? It's basically probe scanning and directional scanning. The services themselves don't actually do a lot of work themselves. They manage objects that are kind of wrapped around like a single solar system in this case. So they would all have like a, oh, that N drop there, yeah. They would all like manage objects that are per solar system in this case. Now we take a closer look at Park, for example. Now Park is managing state for a single solar system. So it's really fun to play with. And as like a former, as a Eve player before I started working at CCP, this is like immense amount of fun. But Park, let's say you're adding a feature to Park, and Park is rather a complex system. It's actually counts 12,000 lines or something of code. It has quite a strong connection with Dogma as well, because a lot of it has to do with attributes and stuff like that. So when you're changing Park, you kind of have to know a little bit about Dogma as well. So both of these then, of course, connect to the DB, and that's always kind of like a source of integration between them, like a coupling between them. But there's more. Park also has a connection, bidirectional connection to scan location. And scan location actually has a connection to Dogma. A lot of stuff has a connection to Dogma. But there's more. There's, wait, hang on. CryMods. CryMods is there. It connects to both Park and Dogma. And then we have other services like loot rights location. And I could go on and on. Like all of these are connected in a very kind of deep way, like referencing attributes of each other. But I kind of want to stop here because I've drawn a pentagram and I don't really want to go further. And I haven't even added in like the inventory system, which basically just giant block over everything there. So this cartoon kind of explains a lot of like the programmer life. Like you have to paint this, you have to draw this immense picture in your mind about how things work. But there are two things like I want to say about that. First of all, you can control a bit how complex this image gets by having like clear boundaries between the services. So at very least, if there is some coupling, it's simple and easy to understand. The second thing I'd like to say is that if you have tests, it's usually easier to get back into what you are actually doing. So you're modifying Park, and you have like some 20, 30,000 lines you need to think about. So how do we deal with this complexity? We really don't. Like nobody has that image in their head. So we create these incomplete models about how the world is. Like we decide that scan manager isn't really relevant here, or Dogma isn't relevant, and the DB doesn't really matter in this context. And we've become really good at it. We touch these files very often, and we usually don't break stuff. But we are humans. And this is an incomplete model. So like that scan manager that we were ignoring, it actually matters, right? And something slips through, like a defect. And it's funny about defects, they get more expensive to fix the later you find them in the development process. If you find them immediately, if you unit test find them, they're really, really cheap. If they escape to the public test server, they are wasting the times of the bug hunters, QA, and they are also take a little bit more time for you to fix because you have to get back into the context. Usually there's a time difference there that you're on to something else basically. If they escape all the way into production, they are annoying you guys and causing us money that way, in addition to all the other problems that they cause. So generally what happens here is that we have 3 types of reactions to this defect that escape to tranquility. The first one, the defect is not that severe. It's we can take some time to deploy a proper fix, understand what the problem is, and just do it at our own time. If the defect is severe, we have to deploy a fix usually the following day. And we may not have time to figure out all the reasons why it got put into production. And we still, it's like a patching job. We just put a Boolean flag in some function. So we still may have to get back to it and create a proper fix for it. Now, if the defect is really critical, we may have to do a live fix. And we don't really have like a rolling update thing, so we use a procedure called duck punching. It's an image of that. Yeah. I'm gonna take it off because it's actually really annoying after a while. But if you're familiar with Python, then you know that duck typing is kind of like if it quacks like a duck, it is a duck basically. Now, this is basically saying like if it's not a duck, we're punching it until it's a duck. And we can do this by going in a live console on the server and just change out functions and stuff like that. It's kind of a risky operation. It requires a cowboy hat and like a literal cowboy hat. Yeah. And it's usually, it derails a few people for like probably the remainder of the day. Wait. Yep. And you still have to go and actually, and when we do this, usually we either fix the issue, that's the absolute best case scenario, or we disable the feature, and you might have seen that before when like a feature we're working on is just suddenly disappears. And it may be done really gracefully, or it may just error. Now you still have to actually check in the fix and deploy it the morning after, and you might have to do like a more proper fix later on. So that's just talking about defects. We also have sometimes put in like performance problems into production. So let's say we do something and the scan manager is really, really inefficient now. But because the scan manager also lives on node with crime modes like Beyonce and all that stuff, they are also under extreme load. And they all start responding to queries really, really slowly. Worst case scenario, we actually, they won't be able to respond at all. They won't send a heartbeat and then die. So if this is like sometimes this is triggered by something. There was some code that happened specifically on that node, and it kills that node, but when it starts up again, it hasn't been triggered, so it's fine, or such. It's not so fine. You lost a bunch of players when it got disconnected. But sometimes it's something in the system, so those addresses get mapped to a different node, which is now under load. And then it gets mapped to a different, so it becomes this kind of roaming cluster killing issue. That's when all the developers sit down and they start to do more duck punching in like kind of frantic effort in trying to fix all the remaining nodes before it takes them all down. Yep. So everybody that has experienced that becomes a bit kind of risk averse, right? Because you have to, you basically, if you burn yourself, you stop playing with fire, right? So we usually have a choice when we are developing our features. We can increase cast timers. That's usually what it boils down to. We increase the cast timer. But that used to be fine like 15, maybe 10 years ago. But in today's age with like Facebook and everything having like instant, like no wait time for anything, it really is a bad experience. And it's not always an option for us. Sometimes we just can't do it that way. We can make smarter caching where we kind of just make sure that we clear it at appropriate times. But that usually means that we're making the code more complex. And that's all contributing to the cognitive load. And it makes the picture I showed you before even more complex because all the bits in there become more complex. And you should always try to make your code as simple as possible. This causes us to do a lot of like premature optimization, like because we sometimes we have a rough idea of what to expect when you put a new feature in, but sometimes we have no idea. You've consistently blown us away with the scale of your operations. So, fun story: when we did the Titans, we expected to be like 3, 4 of them in game. didn't work out so well. So I feel like I painted a pretty bleak picture of this, but in reality, we've been doing this for 16 years, or we've been deploying Eve in production for 16 years, and we've been evolving it, and we can scale the cluster. I mean, our smallest scalable unit is really the solar system, which causes problem because everybody seems to be wanting to be in the same solar system. And we can only scale it up or down during downtime. Our teams can move freely within the code base. Like, since it's a monolith, they can basically go wherever they want. It's mostly just Python code that the gameplay teams are working with. I'd say that is fantastic from like a production point of view, because they can be really, like, they can switch focus really easily. They can put teams around certain problems, but it doesn't necessarily do any good to like the code cohesiveness and what I've learned is it drives you to create more like extra systems of stuff that's doing the same thing, if that makes any sense. And code quality in general is on the rise thanks to code reviews. Some years ago we started doing code reviews, like most teams do code reviews. It's not mandated, but yeah. And if you aren't doing them, you definitely should be doing them. They're really good for both. So one thing is that you can catch any defects you put in your code. The other is it's a great educational tool, especially for junior developers to learn from older developers. And I think older developers obviously can also learn from junior. It should be senior developers, not older developers. We've added in a few automated tests. Philip in his talk about DirectX talked a little bit about that. We have unit tests and client tests, and client tests, it's probably like a full end-to-end test where we start up a server and a client. And better time management, that's really, really important. Just understand what you're capable of and don't overcommit on that. Yeah. So all in all, we're not in a terrible shape, and we could keep going this way for years to come. But we believe that we can do a bit better than that. Software has moved a lot forward in the last 16 years. And I think we've kind of optimized everything we can get out of this system. So now I'm going to hand the mic over to Nick, who's going to talk a little bit about how we're doing this.
Thanks. Yeah, so what Tuxford has been talking about is ultimately the fact that we've done a lot of work with Python. We've done a lot of work in the concept of being on a single logical processor. There's a lot of optimizations that have already been done around that. This is what causes the issues when we start organizing our code in a certain way, like he was talking about at the beginning, where you have to have this giant complex mental model in order to do any changes specifically to a small system. You have to deal with the whole rest of the system. You know, there are situations where, you know, if you went up to a senior developer and said, well, I changed the localization value for this title and now Titans can't undock. And they're like, sounds plausible. So there's a lot of that kind of stuff that we have to deal with and isolate and cope with the boundaries of that. And that problem in general is just the general cognitive load of how we work with the system itself. We ultimately start dealing with the cognitive load on the level of language. So we have a ubiquitous language that we're introducing into the ecosystem. And the importance of that is so that everyone is speaking with the same concepts in mind. Because like the duck punching metaphor, you can make it a duck wherever you want. So with the ubiquitous language, the idea is that it's very specific how you use certain parts of the code base. But more importantly, the ubiquitous language is more around you disconnect from all of these things that you need to care about. So you take Python off the table, take the database off the table, take the interconnected dependencies off the table, and then have a conversation about what those models should actually be. And so we've kind of done that with, we've selected protobuf for our ubiquitous language in this ecosystem. And we've ultimately made 3 classes of primitives within that system. We have events in our system that works as a fact of the universe. These are things that we can then replay objectively, and they represent what has happened in the universe. This is a really big deal for us to do correctly because it also allows us to do things like record BTAC-R and then play it back and see what we can improve upon. We're not quite there yet, but that's where we're trying to get to. The other primitives that we have are notices. Notices are more the subjective version of events. And there's a subtlety there, but these are the kind of things that we send directly to the client as opposed to within the services themselves, because they're not necessarily objective facts, they're a perspective on what has happened. An example of this would be if your structure is out of fuel, that's an event. That is objectively a fact of the universe. If your structure is low fuel, that is subjective. What does low mean? We can't play that back. It won't make any sense. But your client needs to have a notification of that. And client in this sense doesn't necessarily mean desktop, but we'll get to that later. The other ones are request responses. This is ultimately how inside the ecosystem we figure out get more information about a specific event or about specific entities within that ecosystem and how that works. This is important for us because it removes all of these straight lines between services. Because once you try to scale a system and you bring all of those lines with you, you run into some other problems like, okay, how many connections can I have on one actual physical machine? File descriptors become an issue, so on and so forth. And so that's where the message bus comes in. So we have our ubiquitous language to kind of simplify the cognitive load that happens when we're thinking about how this system should work. Then we place all of those types of primitives onto a message bus. The message bus itself is also helping with the concept of those connections between services, because now we just have one connection, that is the message bus. And you might say, okay, well, that's a single point of failure. Yeah, absolutely it is. But the technologies behind the message bus, such like RabbitMQ or Kafka or NATS or NSQIO, all of these types of things, all have many different types of redundancy, high availability, durability in place to deal with that kind of thing. And we can also cope with degradation of that system in a much better way. So right now, we actually have TQ connected to the message bus with this ubiquitous language using protobuf, basically. So that's already in place. You guys got a sneak peek of that at a fan fest a few years ago when we talked about kill mails. And that was actually the prototype system. Like actually CCP Larrikin built the actual system to look at the kill mails and add like the logi data and all sorts of other interesting things. The problem with that is that this was before we had our ubiquitous language. Like that was all JSON. And so it was just a giant pile of data coming out. And then we were pulling all of that and analyzing it and building the kill mails. The problem there is it was an experiment and we left it on. So I think we found that out. I think it was like 2 years ago. There were some decent fights over the summer, and we were wondering why there was 2 people in system and tie-dye hit. It was because of that. So we had to turn that off and kind of rethink how we're doing all of this and how all of these pieces are working. And so that's kind of why we got to the protobuf aspect of things. We're doing a lot more work around solving not only the cognitive load problem around how we're going to organize and think about these things, but also the technical problems around Python and the single logical processor. So one of the things that we're looking into is introducing gRPC into the ecosystem, but I'll get into that a bit later. So the message bus has actually been used heavily, specifically for the Eve Swagger interface, so ESI, the third-party APIs. The Easy is the reason that the message bus exists, simply because of the model of the XML APIs, the model of CREST. Those were things that existed in those complex diagrams that Tuxford was showing earlier in the presentation. We needed something that was decoupled from that, because if we wanted to fix something or stop a major flow of information from happening, or something was going haywire, we need to be able to do that without the entirety of TQ going down. And so that's when the message bus was introduced. Technically, the real reason that Easy came along was because of the first version of Portal. So the actual mobile app, the first version of that came out, also used Easy. Portal 2, that's actually just recently come out, That is going straight to the message bus, and we're converting all of those things over simply because we want to separate Easy and the actual portal app itself. We don't want those to be related to one another because if we don't want to create that same level of criticality there. One of the bigger projects that we've had is the activity tracker. So the activity tracker itself is not built anywhere in the Eve cluster at all. It's actually running outside, attached to the message bus, and that's what's counting everything that's going on in the universe and kicking back all of the data to the client, telling you guys how many things you've mined or how many people have you blown up or whatever the case may be. All of those pieces are happening outside of there. And we'll talk a little bit more about why that was important. But as of right now, things like the activity tracker would go to the message bus, back into the Eve server, and then down to the Eve client. What we'll be doing soon is connecting the Eve client directly to the message bus. This will allow us to do a lot more interesting things where we can get information directly to the client much faster outside of those ecosystems and not have to worry about bringing down all of those pieces. So the pieces where we're talking about the ubiquitous language, the message bus, all of this is in place so that when a developer is working on something, they only have to think about one of these things at a time. That's the important part here. They don't need this entire concept in their head at once. And it's becoming more and more important because we're not thinking of just the desktop client anymore. We have to think about the third-party APIs, we have to think about Portal, and we have to think about any other systems that might be downstream from that. The activity tracker could also be the battle recorder that we want to put in place. If we have a battle recorder, then we have something that we can ask temporal questions about and build way more detailed kill mails in that information. But we need to be able to do that in a place where we can deal with that information real time, which means we have to get it out of Tranquility as quickly as possible. And with the other work that we're doing, that's more about dealing with synchronizing with Python, getting things onto a different thread, and transmitting them on a separate thread so we don't spend too much time of the actual simulation loop trying to tell somebody, pew. That's not what we want to do. Because in those situations, if you imagine 6,000 people in a system, one guy goes pew, and then the system has to go, cool, I need to tell 5,999 other people that a laser was fired. So we're using these systems to kind of offload a lot of that. The message bus does this naturally. This is kind of what those systems are built for. These are built on top of technologies like Erlang, which was built explicitly for dealing with text messaging a very long time ago. And computer science, for those of you who don't know, almost all of computer science has been solved in the 70s. We just keep using different words as time goes on. So we're just catching up with all of these different pieces as we go. The other big problem that Tuxford was talking about is the concept of duck punching in general. Like when he was talking about that there's a defect, that our options are basically how bad is it? And then your options are either make it stop, and then we have to wait for another deployment next time TQ goes down to work with those things. Or you can actually change it into what you need it to do then and there. But it doesn't change the fact that that code needs to then make it into the next deployment. So if you have a problem on a Friday, you're not going to be able to deploy, you probably won't deploy that until the next Monday. So again, it also contributes to this cognitive load of, I now have an engineer who has to make sure that over the course of the next 2-3 days, he either punches ducks or makes sure that his code gets deployed in the proper time frame. So a big thing that we've done with this kind of stuff, and the activity tracker is the perfect example of this, is we're using technologies like Kubernetes to do orchestration for a lot of internal services. And activity tracker is the first player-facing service, you could say, that is using this kind of technique. And so we're basically able to put these services onto the message bus and interact in the same way that you've seen the activity tracker work. There's a lot more stuff going on behind the scenes. What CCP Larrikin has been talking about with the bot and law and order work that's been going on, these services are using the message bus. They're reacting to things in real time. The older way of doing this has been, going through 200 gigs of logs and figuring out what's going on. But there's much more that you can do when you can ask a question immediately when something happens. Now, in some cases, with the activity tracker, we had to shoot it in the face. And then that's fine, because what would end up happening is we would just have 2 more that came back. So when we deployed the activity tracker, there was a lot of conversation around, should we backfill all of the data ever in the universe for all of the numbers to count everything? And we're just like, let's just deploy it and let's see how that goes first. And so we actually deployed it before it was available in the client. So it was actually sitting on the message bus. No players knew about it. It was tracking everything going on in the universe. And we were able to do this without having to worry about bringing TQ down or affecting any other services that were going on in the server itself. And then we're the ones that shot it in the face. Because on deployment day, we're like, okay, let's just reset everything. We start from now. Let's just see how this plays out. And that's kind of how Activity Tracker was rolled out and developed. Now, keep in mind that a lot of this is kind of the philosophical aspects of these, but this meant an entire team had to learn protobuf, the ubiquitous language. They had to learn a completely different tech stack. None of their information is being persisted in the TQDB. It's in their own DB. So they had a whole suite of things that they had to learn to work through. And that was kind of our pilot program to see what that looked like. And we have a lot of stuff that we can improve there to move forward. But then we get into service degradation, which, depending on how severe of the defect is, we might get that by default and you don't have a choice. But ultimately, with things like the activity tracker, we are going to start a crusade, for lack of a better word, to go through anything that is not in space, basically, and work through and pull all of those out to these separate systems. That way we can roll through and update them and change them like you want, like we want to see. Like a lot of the changes that we hear when we're at FanFest or Vegas or any of the player gatherings, all of those things become much easier to change when we don't have to change the entire war machine that's going on to TQ. So we'd rather, if mail broke or we added something to mail, who knows? We'd rather this happen, but instead things like this happen more frequently than we would like. And so that's about separating kind of, we would rather, I think this has happened maybe once since the activity tracker has been out. People open it and everything's zero, and but it was fine. It was just the fact that the service was taking a nap. And then when we brought it back online, all the data came back, everything was fine there. And that's a different level of degradation. Ideally, we would tell the client, hey, things are broken. No, don't worry, don't freak out. And so this is a look at the current ecosystem that we have right now. At its peak, we're probably doing about 1,000 events a second. That's just events. That's not counting notices or requests and responses. Easy by itself on the message bus represents 6,000 messages a second, 3,000 requests, 3,000 responses. And that's just for the third-party API stuff. So Easy is definitely doing more work than the Eve desktop client itself. But for the events themselves, the activity tracker is consuming about 600 of those a second as far as the events that are being pumped out right now. The other 400 are probably split up between various other services like bot detection or any kind of other analytics that we're doing. There's also, I think, some of the contextual offer services are using this as well to see, like, we use this as a terrible example, but it's like, hey, I see your ship exploded. Would you like to buy another one? Those types of things that we can react to, right? And these are kind of other things that we talk about every now and then. Like, we would like to build, play with the concept of like SRP and use that idea to funnel into these kind of reactive systems that we can build with this information. We've done some rough numbers. If we migrate absolutely everything overnight, it's going to be about 100,000 messages a second. That's where you get the numbers that you hear, about 200 gigs of logs. And when we had the damage events turned on, by themselves, those were 6,000 a second, which is why those fights a couple years ago were problematic. And also why we haven't been able to roll out the kill mail things, because we discovered this and we're like, there's way more work that we need to do here before we can make that live at all. Another piece of this kind of paradigm change in the development is around the technology independence. We've talked about this a bit already, but most of it comes around the fact that our technology trajectory, we don't have to move everything at the same time. There's a lot of projects that we have going on. You've heard about DirectX 12, the 64-bit client. A lot of that's involved with that, as well as migrating from Visual Studio 2010 to 2017. A lot of things happened in 7 years. But there's a lot that we have to pull along with that to get those kind of things done. And so the concept of switching from Python to Golang to Rust or whatever those might be become much easier thoughts to have because the surface area is so much smaller. This also allows us to play and experiment a bit with how we use these systems. Yet another good example with the activity tracker is the initial data storage for the activity tracker is in Redis. And if anyone asks you to ever use Redis as a persistent storage, tell them no. Because RAM becomes a problem real quick. And so what we're doing is we've already set up an experiment where we're migrating it to Postgres and all of this different kind of stuff. And so that was much easier to do because it was much smaller surface area. And yeah, I think that covers a lot of what we wanted to go over today. We have a roundtable immediately after this. We're gonna show a little toy that we've built to kind of illustrate the message bus and what we can look at and visualize with it and what we can see. But yeah, thanks for coming out. And I think, do we have time for questions? Great. So if there's any questions, we can go ahead and take some now as well.
With the Q&A, if you want to ask questions, go for the mic.
Yeah, the mic right here.
Think of the people on the stream.
From some of the other presentations, it sounds like you're moving to a agile software development process.
We have always claimed to be agile. That's not oh, wait, since we did Apocrypha, then we were agile. But yeah, there are certain things you should have in place when you're doing agile, such as unit testing and stuff like that. So if agile is a scale, we're on it. I think we're closer to agile than not agile, but yeah.
We're definitely on a spectrum of some kind. I think to kind of clarify a bit, it's more the technical work that's been done. Sorry, not even the technical work. So art, sound, code, all of those things have been in an agile concept. I think the main thing from the keynote is mostly what you're referring to there is that if you think back in the past of how we've done FanFest in the past, there's always been this giant overview of what we're going to try to do. I think the point that they were making there is that, you know, we've been doing agile since what Tuxford said, but the strategy has become more agile. It's not that we're like, okay, everyone's getting their own Stargates in 6 years. It's like, well, okay, maybe not. Like, let's see what happens in between those times, how the players react to certain things. You know, we need to think a bit more about the follow-up and reacting to that as opposed to continuing on with those concepts. Like Tuxford was mentioning, you know, there's only supposed to be like 5 Titans. That's not the case. No one would ever live in wormholes. That's not the case. So I think it's more about, the agility is more about shifting on the strategies of what we've put out and reacting to those pieces instead of just the functional parts of it.
I'm curious, with the layout and the transitions that you're talking about, bringing the message bus and integrating more of the services to a more direct connection, the term postcode has been tossed around as like the magic fix-all at this point. If we can just do that, we can do everything. Where does that kind of lie in any way with the diagrams that you were discussing?
So ultimately, if you were to build a game right now, if you took Unreal Engine off the shelf, you would do 2 things with an ecosystem like that. You would, 1, maintain your connections with Unreal, so all of your, you know, bullets, covering, running around, all of those things would still be the Unreal Engine replication network system, right? But then you would also have this secondary system where you would connect to your services, like what's in the store, or your persistence or progression, and usually those things are implemented in an HTTP kind of online subsystem that might roll into Steamworks, it might roll into PlayStation Online, Xbox, whatever, yeah. Right? Like, those would be your 2 primary connections. Mm. So with the postcode stuff, it gets more into what Tuxford was talking about with like Park and Dogma and those kind of things. As we move forward with this strategy, we will try to achieve the idea of what you would do starting from scratch now. Mm. Where first, you know, in the slide that I was showing all the services in the Neocom, we want to clear those off the table. Because the sooner we can clear those off the table, the easier it will be to reason about the more complex pieces that are actually complex. Not just complex because there's a lot of them, but complex because we have to deal with simulation, deterministic physics, all of those kind of things. So the general strategy is to basically clear the table so that we can think more about those things particularly.
Love it.
Hey, so I was sitting in a Nix waiting for a Keep Star fight a while back, and after something like 5 or 6 hours of tie-dye, they were like, yeah, we're not going to drop supers in there. It's just going to mess the servers up too much. And I was thinking about this quite a bit. And one of the solutions that I had kind of come up with was something like a message queue that, like, if you have, and you just kind of covered that that's like a road that you're going down. But like specifically with regard to a fight, like if you had a thing that was like a bomb, I'm sure is just like an awful thing to like process when there's 6,000 people in the system. You can't just like toss a message out that contains the state of everything. Like it's too awful. But like, have you done the POC of like shared RAM on the same system doing something to like offload to other processes?
We haven't done a proof of concept. We talk about this quite a bit.
Oh, okay.
The original incarnation of this plan was actually a lot of IPC in place, so that we would do potentially shared memory concepts. But ultimately, the point of this project originally was about maintenance. Because the bigger problem for us right now is that we can't even make things better because tentacles come out of nowhere. And
cool.
I don't even want to care about that.
Awesome.
So initially, this was about maintenance, which is why we try to get off the box as quickly as possible. But there have been lots of conversations around that, of where Tuxford has tried to find any and every way to introduce a Neo4j dependency anywhere he can. But the idea is there, right? We would offload the building of an object graph.
Cool.
And then when a bomb goes off, we would ask the object graph instead of trying to calculate it on that node. So there's a lot of things that we've talked about in that kind of situation.
That's super cool. Thank you.
A lot of the load comes from the poorly named dogma service, and it's something that I feel like I'm almost ready to start thinking about again after the last brain in a box. So, and yeah, that became a lot of the ideas we have about that is trying to, if you are familiar with brain in a box at all, it's basically means that we do all the calculations from the skill management on the character nodes themselves, and then they just give you back like the inputs into the ships, because a lot of what's happening is like modifying attributes that modify attributes and like those sort of things. We kind of want to do that, but on like a ship level, which is why we were calling it ship in a bottle.
Thanks.
As far as mentioning what the proxies that you use to route all your traffic to the nodes, is that all something that the data center in the UK does all on their own, or does CCP host that themselves?
That is a CCP thing, and like I said, it's running identical code to the server as the server do, just not on a, just doesn't have a connection to a database. But yeah, that routing goes on in there.
Hi, good morning, guys. Kadia Say of Signal Cartel. You answered the why you didn't retroactively fill the data for the activity tracker, and I might be a little biased asking this question, but could you now, at least for systems explored?
Yeah, thanks. I mean, we could definitely go back and do that. There's a significant amount of the issue is, well, I mean, we definitely have it. So if anybody's familiar with the third-party APIs, we once had an endpoint which was character statistics. And we would run a gnarly SQL script to generate that at the end of every year, and people had yearly stats on what their characters were doing. The problem was that got to a certain point in the year where we tried to run that, it would just fall apart. Because so much has changed in that time period. So for us to go back in time and with any level of confidence be able to tell you that those numbers were correct, there's a lot of work that goes on there. There's a temporal problem there where we could probably go back a few years easily, but then after that, we would basically have to offline the data analyst and be like, guys, tell us if this is correct or not.
Yeah, thanks.
So that's the conversation that we had internally, which is why we're just like, let's just put it out there and see what happens.
Yep, That's fair enough. Thanks.
Have you looked at GraphQL at all for a future ESI?
Yes.
I love you.
Well, let me finish.
Well,
We have looked at that. There's a couple things there. One, internally, we're heavily talking about what we're exposing in the third-party APIs. There's a lot of situations where we've exposed more than we should have. Even from the transition from Crest and XML to Easy itself, there's been a lot of things that we just cut out. I'm one of the people on a giant GitHub issue that people have ranted many times at me about, where we've removed things like the account information.
yeah.
Omega and alpha status, these things that blur the lines between the game and an actual human in the world, we have to err on the side of removing the human concepts from it. What's been talked about more recently, actually, is potentially moving to gRPC, and we would just publish our proto definitions, and we could go through there. But we're still toying with that idea, because ultimately the GraphQL part, it's a bit more interesting, but we still need control over which pieces. We can't just have an open inventory of make a crazy query and then hope our system survives.
Oh, yeah. Yeah, the main cases I was thinking of are the things where somebody was building like a nav thing in our alliance, and they were like, I would love to have this data as JSON. I don't know how to do it. And I was like, well, okay. And it was like, get all the systems in, you know, you have to walk your way so far down. You end up doing this like, 500 queries, and all I wanted to do was get all the Stargates and Fountain.
Yeah, the static data concepts has been something that we want to talk about more as well. Like the SDE, Fuzzworks deploys all very different versions of that, but ideally we'd like to get to the point where we can use ESI and then basically say, hey, you can build all your static data however you need to build it. Because of the question that you were asked, like that's the problem that we can't solve. We can't solve that for every person's version of whatever
Yeah, because
format they
everybody
want.
has their own kind of way. Everybody has their way they want you to structure the data, and
Yeah,
that just
exactly.
doesn't work. Yeah, exactly.
And this
So-
is why we chose the open API, the Swagger interface generation stuff. We've talked more about potentially gRPC simply because we couldn't find a low maintenance version of WebSockets that we liked. Because ideally we want to push more data to you guys, as opposed to you guys asking us 5,000 times a second what it is now. How about now? How about now? How about now?
Yep.
But yeah, that's something that we definitely talked about more. Are we
Cool.
We're done. Okay, so then we can continue on at the round table after this.
Thanks.
Thanks, guys.